nuts, minus n times x bar is the mean of x. And now you got to square that. You guys want to do that the rest of the night? You want to do that on a test? You want to use SPSS. Who's your buddy? SPSS, right? So now again, x bar is equal to summation of all the x's over n. So and we'll show you this in a second. Y bar, it means that, yes ma'am.
What is n?
N is always your sample size. I'll show you that in a second. I'll tell you what. Better here, better here, better here, right? So what's in here? Tell me can you count? I don't mean that literally. I'm being figuratively. I'm not being ignorant, right? How many do we have for in here? We got 1, 2, 3, 4, 5, 6, 7, 8, right? We got 8 data points, 8 examples. If I have 4 wins, a team had 4 wins, what was their attendance? 36,300. This one had 6 wins, it had 40. Looks like more wins, it went up. Here, now this one had 6 wins, but it's 41,000, right? Do you see a trend? What's the trend? As the wins increase, here's 8, it went up to 53. Now, could we have 8 and it could be like 21? Yeah, that might be an outlier. We may have to throw that away. That might have been the 1968 Mets or something, Do you see what I'm saying? Yes, sir.
Isn't this equation y equals a plus bs the same as the slope of the line?
Sure. Well, the slope of the line is this one. Here's your slope of the line right here. This is a slope, this is a constant.
Okay.
Yeah, so this is your slope. Now, don't be taken in by b subscript 0. They're using different terminology here. But we're going to show you how to do both of these. So let's take a look here. Do we know the number of wins? What's wins? Why does it say x for wins? X means that it is what kind of a variable? There you go, right? Independent variable, right? Didn't I put that on there? Y means that it is the dependent variable, right? As I increase the wins, it has an impact upon the attendance, right? Can I add all of the wins up here? 4, 6, 6, 8, 6, 7. What do I get? 49. What would x bar be then? 49 divided by 8, right? I got x bar is number of wins divided by n. What is y bar? You got to add all these up and divide it by 8, right? You guys want to do this rest of the night? You know what I mean? Now, isn't this fun? Now, what we can then do here, here's our attendance. We add it up. That's our y. Now we got to take x times y. Now, SPSS is doing all this for you in the background. 4 times 36.3 gives me 145.2, right? 6 times 40 gives me 240.6. 6 times 41.2 gives me, somebody, 247.2, right? Now, if I take 4 times 4, what do I get? 16. That's my x squared over here, right? 6 times 6 is 36, right? Now, can I add all the x squared up? 311. All right. Now, if we go and we start plugging in here, do you know where did the 49 come from? Like I say, better here, better here. 49, 49, right? And what else does it say we have to do? 8. Why is it 8? What's another name for 8? Give me a letter. N, right? So if I can get x bar, the average is 6.125, right? Can I do the same thing for y? Add all these up. What am I going to take? 346.7 divided by 8. What am I going to get? 43.34. Unless the damn graduate assistant messed me up again tonight. There's something wrong in there, right? Now here's your rise over the run. We got to do this, right? So what is the summation of x, y? 2167, right? Where do we get 2167? Right there. We had to take x times y, and for each one of these and add them up. You want to do this, or do you want SPSS to do this for you? Huh? Yeah, SPSS. You want to do this on the test, or do you want to make sure that you review? I've taken the entire universe and I have distilled it down onto D2L for you. Where would be a good place to look for things tonight on D2L? Give me a
Notes.
Well, yeah, notes, but give me a key term here of all the things under content that I could look under. Should I look under linear programming tonight? Should I get on the computer tonight and send Dr. Roger an email and wonder why I can't find the things tonight under linear programming? Would that be a good thing to do? Would you look under linear programming tonight? No, okay. Would you look under, decision sciences tonight. No, what, does anybody have an F word for me? Forecasting. Very good. Very good. Mr. Rogers' term of the evening is forecasting. I would, before I got on the phone, on Hangout, on email, and started raising hell with Dr. Roger, I would take a little time, because what would have happened had I not distilled the entire universe down to D2L? Where would you guys be? I spent all my time building this up for you, and then you still, it's like you don't want to take that little extra time. But that's all right. That's why I'm here. It keeps me in a job. It gets me trips and all that stuff, right? So here we go. Can you substitute all of these in, and can you then come up with this? This is this term right here. This is X1's this one. This is a B1 here. This is what we're going to have. Now we also have to come up with a B subscript 0, which is really this A. And do we know what Y bar is? Right? Minus, do we know what B is? Right, here's B, right? We had to do B first. And do we know what X bar is? That will give us this number. And therefore, we will come up with a regression line that says that Y is equal to 18.46, this constant right here, plus 4.06. That's what this rise over the run was, times, if I wanted to take a look, at 7 wins, what should have it been? Well, we already know what 7 wins, what somebody else might have had at 7 wins, maybe. Do we have, here was 7 wins, and they got 47,500, and here if we used our regression, we'd come up with 46,880, right? So if I would ask you what happens, let's look into the future, and they get 16 wins, what are you going to do? Who are you going to call? Ghostbusters, right? Y is equal to 18.46 plus 4.06 times 18 wins? Yes, sir.
The Y value that you got, not the Y value, the A and B values that you got here, 18.46 and 4.06, that is dependent on the number of samples, which is 8. Wouldn't that vary if the sample increased by one size?
Well, that's what I'm telling you, my friend. What is, have you ever flown an airplane? Have you got a pilot's license? You are? Okay, what's your friend? What's the best friend you have as a pilot? Altitude, right? I got altitude, I got time, I can, I can, find a nice spot, Don't pick the one with lights, don't pick the one that's dark down there, because it's probably a river. If it's at night and all that stuff, which is more dangerous, actually, taking off or landing. Taking off, because I don't got altitude, I take that some bitch off, I'm 20 feet off, 100 feet off the runway, motor gives out, right? But I'm coming in here, and I'm high up there, you turn final, you check to make sure your carburetor's not frozen up, you go on the full tank, all that kind of stuff, right? You turn final, you come in, you glide her down, and basically all you do is right when you're ready to hit ground, pull back on the power, stall the whole damn airplane, bang, she hits, right? Any good landing you can walk away from is a good landing. Now, what does that have to do with this question? What is your friend? A pilot's friend is altitude. What is your friend in statistics? What's the biggest friend you can come up with?
Sample size.
Sample size. Bigger the sample size, the better the chance of you estimating what that entire population is. So I gave you 7 or 8. That's all I got. By God, if you can get out there and get me 30, your regression's going to change, and it's going to be that much more accurate, right?
Okay.
Yeah, that's...
No, if, hypothetically, if you have one more sample added, and that sample size is way off the limits than what you already have.
That's called an outlier, you know what I mean?
Yeah.
And if what you have to do, again, my friend, you might be a good candidate for the doctoral program if we ever get that going, you know what I mean? Because what you're doing is you're asking a bunch of questions that they're very appropriate, but they're beyond the scope of this class, because you're gonna scare the hell out of these guys, and it's more information that you need. There's things called stem and leaf, right? And what you have to do is descriptive statistics on it and see, again, when can I do regression? When can I do regression? If the data is what? What does the data have to be for me to do regression?
Linear.
Yeah, linear, parametric. If it's not, I have to do that stem and leaf and descriptive statistics to see if indeed this is a linear relationship to begin with before I can apply this. Now again, we didn't go through that here, right? But that's basically what you're supposed to do. So what I'm saying is, if we did baseball attendance, this is an old example, but if you looked at maybe the Yankees and the Dodgers, you know what I mean? Or the Mets, they may have been outliers, right? The Dodgers, everybody's, it never rains in Southern California, but it does snow, and everybody's doing something else besides watching baseball games in Los Angeles, you know what I mean? And if anybody's watching a game, they're probably high while they're doing it, And the Mets were so bad, nobody would be caught dead there anyway, right? What you have to do is you have no problems with throwing those out. You want the best estimate. Look here. And again, so you're getting the whole, we're way off course, but what happens is, these are error terms right here, right? That error should not be more than 3 at the most. If you go through and you do the errors, and you got some bitch down here, get rid of it. I never saw it before in my life, you know what I mean? See, it's not only the accountants that can cook the books, statisticians can do it too. Right, so anyway, that's the answer to that, right? I don't know did I sidestep it? Do you understand what I'm saying? Yeah.
You basically eliminate that.
Yeah, I mean, we want to do the best we can. And again, if you see the rest of this, there's all kinds of other things here. We can do forecasting using moving averages. We can use, 3-period moving average, 5-period moving average. We can use alphas and betas, which I didn't go over here yet because we didn't get to it yet. But of all of those, you're going to find which one do you think is the best one? The best predictor, in the short term at least. Trend analysis. Regression. That's what it's not going to let you down. The error is going to be smaller, utilizing a trend line than it ever is going to be using exponential smoothing and moving averages. Okay. At any rate, are you lost totally? You somewhat follow? Okay. And again, I'll make it real simple for you. So here again, this picture is better than my picture, right? And now another thing is a correlation, right? We can come up with an R value. Now again, guess who can do R values for you? SPSS. Also, if you guys love Excel, they can do it. Minitab can do it for you. We can do it in MATLAB if we want to. But I pick SPSS because you guys, I'm going to tell you again, you can download this from the IT support and the very security of your own home can do SPSS tonight when nobody's looking, right? You can even have a party and roll in a keg and do SPSS together there, right? Again, we have values that are on R that are between plus and minus 1, right? So if it is a minus 1, what do you think occurs? The correlation is negative. It's an inverse relationship, like this. If it's 1, it's a positive relationship, right? What do you think the correlation is between Roger being fat and Roger being overweight? High, right? What's the correlation between Roger in pounds and Roger in tons? Percentage of it, or stones, or whatever the hell you want to measure, right? There's a high correlation between it. It's 1-to-1. You're actually multicollinearity. You're measuring the same thing. But this is what, what else, what else would there be a high correlation? Can you think of anything? Give me an example. Taking my test and being drunk. Probably a high correlation. The more drunk you are, the better off you probably feel and do on the test, So, again, if it's 0, there's no relationship. If it's minus 1, that means it's an inverse relationship. If it's 1, it means that there is a positive relationship between that, right? Which way am I going here? The wrong way? Now, so here's R. Again, can we come up with R? What did it tell you here? Do we know where to get all these numbers here? You guys want to do R all night longhand? How about if I give that to you on the test in 2 hours? How mixed up do you think? That's when I was a kid. That's the way we did it. Hell, you had to memorize the damn formulas. Unless you wrote them on your shirt on the inside there, or on your handkerchief or whatever, right? So here's R. Now, if we take that R and we square it, so the R, when we're done, is 0.948, we get an R squared of 0.899. What does R squared? That's also called the goodness of fit, and it is the squaring of the coefficient, correlation coefficient. What does 0.899 tell me? Anybody know?
Strong correlation?
I'm sorry?
Strong correlation?
Well, what it tells me is that almost 90%, 89.9, almost 89% of what's occurring here in attendance has to do with the number of wins. I picked a very good one. This B1 is very good because what could I do? This is what called a what? A simple regression, right? If I don't have simple regression, what do I have? Multiple regression, right? Like orgasm, multiple orgasm, right? Did you guys come back again? Huh? Did I get you woke up? Right? Okay. So what do you go here? Y hat? Did Eric get that one, or did he fall asleep on it? Has he got a girl in the room?
No.
Well, he's okay. Does he have multiple girls in the room? Does he have multiple boys in the room? Plus B1 X1 plus B2 X2 plus B3 X3 whatever plus EI, right? Still they haven't given me a pen that works here. I'm down to my last one, right? So what we're saying is that this gives me a very good indication that if I have more wins, I will have higher attendance. Now, what do you think would be something else that I could add to it? If you wanted to add another variable besides wins to increase my attendance, what else could you do? You marketers out there.
Fireworks.
Fireworks, there you go, there you go, fireworks, right? And beer, give them free beer, right? Promotion, right? If I promoted it on TV and all that, that may add to it also, right? So like I said, now again, really, if you're into cooking the books, you start getting up close to a 1 and you try to publish that paper, they're going to probably throw it back at you and say, wait, that's too damn good. You know, I even had my dissertation chair told me, oh, now wait, you better mess around with those numbers a little bit. That's too good. We don't want that good here. You know what I mean? You know, put another variable in there so it comes down a little bit, right? But you know, the damn marketers back in the 60s, they were running a profit impact and marketing strategy and the Boston Consulting Group. I bet you them bastards are still teaching that to you here in the marketing. Huh? You guys get the Boston Consulting Group in your marketing classes? I mean, they're not going to tell you about the cash cows and the problem child and all that stuff. Yeah, the marketers haven't moved beyond the 60s.